Everyone, welcome to your PlayPosit for the week. Today we're going to be covering Unit 2. So we started Unit 2 a little bit in class on Tuesday. Excuse me, let me grab my pen tool as we're talking. We're going to finish up our notes from Tuesday. It was just one tiny slide and then move into 2.03. So go ahead and grab your notes and have your PlayPosit graded assignment open. So this is from last class. Remember we were talking about polynomials, poly meaning many terms. So something with many terms. And I'm just going to put up another example here. I used random examples in all of my classes. So if you do have notes on this page, that's totally fine. You can just kind of confirm the same kind of terms that we talk about, or you're welcome to add to this slide or turn your paper over and add to this topic here. So I'm gonna put, let's do 2xy squared plus 3x plus 4. So this is just an example of a polynomial. So we talked about some things, right? We talked about terms. And remember, terms are separated by addition and subtraction. So how many terms does this polynomial have? It has 1, 2, 3 terms. 3 terms. Okay, then we talked about coefficient, which we have learned before. Remember, the coefficient is the number in front of the variable. So for example, if we're looking at this term, the coefficient would be 3. It's the number in front. If we were looking at the first term, the coefficient would be 2. So it's just that number in front. Then we talked about the degree of a term. So the degree of a term is when you add up all the exponent values. So here's an example. The degree of the first term, the degree is 3 because we have an exponent of 1 here. 1 plus 2 is 3. So I don't want you guys to get this confused with our exponent rules. You know that previously, if we were trying to simplify this, this is actually as simplified as it can go. Because x and y are different bases, we cannot combine those exponents and saying like xy cubed. That's not what we're doing here. To find the degree, the process is to just add all the exponents. Let me pull another example that's not in this polynomial. What if I had something crazy like this? All kinds of, that would be 1, 2, 3, 4. That'd be 4 space. Cannot graph it very easily in 4 space. I could show you guys in 3 space. That would be nuts. But just to show you the degree, all you do is you take all these exponent values and add them together. So 7, 9, 10. The degree is 10. That's it. So then we have something called the degree of a polynomial, the degree of the whole thing. So you can find the degree of each term, and then you can also find the degree of the whole thing. The degree of the whole thing is the highest degree. It's the term highest degree. So if we look at this one, we can do the degree for each term. Let me grab a different color. So the degree for the first term we said was 3, right? 1 plus 2 is 3. Degree for this term is 1. There's just one exponent. The degree for this term is 0. There are no variables, and so there's no degree. Okay, so the highest degree is 3. So that makes the degree of the entire polynomial 3. There's something else special that comes from that, and it's called the leading coefficient. So we talked about the coefficients for each term, right? Like here, this example, coefficient was 3, coefficient was 2. But to find the leading coefficient, sort of the one in charge, the one in front, it is the coefficient of the highest degree. So once you find the degree of the polynomial, and usually you'll hear mathematicians and teachers and books and stuff say degree, and they just mean the degree of the polynomial. So the leading coefficient, first we go to the term that has the highest degree, and that's this one. And then you just take the coefficient of that term, which is 2. I think that about wraps up important polynomial terms. So now we can do some examples. This says name each polynomial by degree and number of terms. So number 1, don't forget that you guys can pause this recording at any time and try these on your own. So the degree of this polynomial is 4. It is the highest exponent value of those terms. And there's none to add together, right? Because each term just has one variable. All right, and then this has 2 terms, so that is considered a binomial. Remember that game we played last class? This is just one more practice with that. All right, number 2, the degree is just 1. This variable here just has a power of 1. And this is a special polynomial. It's a monomial. Remember, monomials have only one term. And we can just add in here. I didn't ask for this, but what is the coefficient of that? The coefficient is -10. Don't forget to take the sign with the number. All right, number 3, the degree is 2. Oh, this is funny. And the coefficient is also 2. And this is also a monomial, just one term. Last one here, we have a 2-term polynomial. That's a binomial. You guys can think of bicycle with 2 wheels. And the degree is 2, right? These were kind of easy on the degree front because we didn't have any like additional variables to add together, right? They all just had one variable in each. So before we move on to our next sort of topic, I wanted to do a flashback and review how to simplify expressions. So remember that when you're simplifying expressions, you can only combine like terms. So here's an x cubed term, and here's an x cubed term, which means we can go ahead and add those together. So 2x cubed plus 6x cubed is 8x cubed. Now we'll collect our x terms. -4 minus 8 is -12x. And then we have our constant value, -7. And that's it. We can't go any further because these are all different types of terms. We have a cube term, an x term, and just a number. So we've done this in the past, and kind of just to throw in what we just learned, how many terms does this have? There are 3 terms. The degree, remember that's the highest exponent value of any term. And in this case, again, we only have one variable, so we don't have to add any of them together. So it is 3. And the leading coefficient is 8 because that's the coefficient with the highest degree value. What else? This is the constant value, right? It's never going to change. There's no variable with it. Oh, and it's a trinomial. There are 3 terms. Tri meaning 3. This is also a cubic. Remember we saw that in last class, where it's going to have 3 pieces, so to speak, or 2 turns. It's going to have that shape or this shape, depending on some values, which you'll learn in Algebra 2. But it's kind of cool just that you can get an idea of what they do look like. All of this is Algebra 1 stuff. And we're not actually going to graph these by hand this year. Okay, let's get to it. A lot of people really enjoy this topic because it feels very mathy. You know, it doesn't feel very abstract. So I'm hoping that you guys enjoy it. All right, so we're going to add the polynomials. See, we have 2 polynomials here, essentially, kind of, right? A binomial plus a binomial. 4 total terms. So it's telling us in the middle to add. So that's all we're going to do. We're basically combining like terms again. So we're going to do 5p squared plus 2p squared. That's 7p squared. And then we have a cubed term and just a constant. Now it's funny I wrote it like this. I kind of just started left to right. But usually a good idea is to write the exponent values in descending order. So the largest one first. And that's just going to help us find the degree very easily. Because again, in this case, there's only one variable. So we don't need to worry about adding those exponents together to find the degree. So if you look, it's a trinomial, 3 terms. The degree, the highest exponent value is 3, this 3 right here. And the leading coefficient is -3. The constant is -3 as well, this one. All right, cool. So that's adding polynomials, something you've already done before, like we saw in the SOL flashback. It's just combining like terms. So now we have subtracting polynomials. So this one gets a little bit different just because you have to take care of that negative. So having the parentheses is super helpful. So it kind of helps you see, oh, I have this negative here, and whenever I have something in front of a parentheses, I need to distribute it. So whenever, remember this, if there's no number here, you could always write a 1. So we really need to do -1 times everything on the inside of this set of parentheses. That negative is going to affect both of these terms. So we're just going to have the first set, and then -1 times 3a squared is -3a squared. -1 times a negative is a positive. So you can see how that changes that sign in front of that term, both of them. Now we can go ahead and start combining like terms. So we have an a cubed plus 4a cubed. That's 5a cubed, right? 1 plus 4 is 5. And then we have a -2a squared minus 3a squared. That's a -5a squared. And that's it. This is a binomial, 2 terms. The leading coefficient, oops, I skipped degree. I usually do degree first because the degree helps you find the leading coefficient. The degree is the highest exponent value, that's 3. So you go to the term that has the degree in it, and that's the leading coefficient, the one in charge. Usually it's the one in front, but it's the one in front when you put the exponents in descending order. Super easy to see if you only have the one variable. If you have to add anything together, then you kind of have to do that first. All right, here's another example you guys should try. These negatives can get a little funky sometimes, so it's good practice. We're going to have 4n minus 3n cubed, -3n cubed, and a -4n. There we go. Let's combine. -3n minus 3n is -6n cubed, and then 4n minus 4n is 0. That's it. So we have a monomial, a one-term polynomial. The degree is 3. The leading coefficient is -6. Something we haven't really connected yet because you don't really have to know it for Algebra 1. But the degree oftentimes, usually, I hate to say always, but will tell you the number of turns the graph will have, or the number of pieces. So again, this is a cubic, so it's going to look something like this. So you kind of have those 3 sections, right? The up, over, up, degree 3. A quadratic is a degree 2 and has that down and up, or up and down, or left and right, depending on how it's oriented. So that's pretty cool to look at. So you guys have a lot of exciting things coming in math. All right, so they can get a little bit longer. I don't really think they get harder because you're doing the same thing. It's just that there's more terms. So you do have to keep things sort of organized, right? So we have a plus in the middle here, which means we don't have to worry about distributing anything to this set because the positive is not going to do anything. So some people like to rewrite the terms next to each other, and that's cool too. We can put the to the fourth terms there, and then the squared terms, and then just the constant values. Oops. I would caution you, just make sure that you're copying them correctly. It's very easy to lose a negative or change the sign to make a mistake on copying. So I'm just going to double check. Negative 4k to the fourth, negative 3k, positive, negative, positive, negative. Okay, let's combine. So negative 4 minus 3 is negative 7. 3 minus 14 is negative 11. And then 14 minus 8 is 6, right? Yes. Okay, cool. Now we're in descending order. That's nice. Very helpful. This is a trinomial. It's a quartic. It's going to end up having the 4 turns or pieces. The degree is 4. That's the highest exponent value. And there's only one variable, so that's easy. And what else? Oh, the leading coefficient. That's the number in front of the term with the degree. And I guess we could talk about the constant. Not really something you list, but it doesn't hurt to point out. Now let's recall some rules about multiplying. So remember, when you multiply two variables that are the same base, right? X and X, they have the same base. You're allowed to add the exponents. So when you multiply same base variables, you add the exponents. That's a rule that we learned a few weeks back. Remember, this is a 1 here and a 1 here. So we have 3 times 2 is 6, x squared. 1 plus 1 is 2. Here we can do the same thing. It's just written a little differently. Remember, something right next to a parentheses also means to multiply. So when we multiply y times y, you get y squared because 1 plus 1 is 2. So we're going to have negative 8y squared. So this is going to come in handy because we're going to talk about multiplying polynomials. And you guys have done this already. You've just not really done it with a variable in front. I don't recall. We've seen things like this where it's just a number in front. So you've actually been doing this and you just didn't maybe realize you were doing it, that you were multiplying a polynomial. So we're going to do the same thing. We're going to distribute. So 6v times 2v. 6 times 2 is 12. V times v is v squared. Plus, we have to do it to everything, 6v times 3. 6 times 3 is 18. And then you just have the v, right? Because there's no v with the 3. All right, let's distribute the negative 4. Negative 4 times v is negative 4v. And negative 4 times 1 is negative 4. That's it. So we reviewed adding, subtracting, and multiplying polynomials. We are going to do a little bit more with polynomials, but hopefully this felt sort of familiar. I'm not going to say it's easy because I don't want to downplay it. You know, you guys are taking a high-level course, and I'm super proud of you for that. But I feel like it's straightforward and familiar. The familiar part, I think, is awesome because it gives you a frame of reference, right? Like we've basically done this before. We're just giving it another name, the polynomial name. So I do have some practice for you guys. There are only 3 questions to practice what we just reviewed, what we just went over, and it's a class pick. So I'm going to put the link in the PlayPosit so you can click it. And I'm also going to try to put the link, I will put the link on our Class Connect recording tracker. So you can always grab it there. If you're watching the View Peer link, then you can always just go to classkick.com and enter this code. So I look forward to seeing all of your submissions in there, and you guys can you don't have to log in, remember, but please put your last name, first initial. Oh, I have it here. Perfect. Enter your last name, first initial. All right, you guys, check that out. I am at 20 minutes, and we still did some very valuable learning today during our PlayPosit. So thank you for listening. Thank you for participating. Please watch this. Well, you won't know this unless you're watching it, but I hope that you finish this before our class on Tuesday and have a great weekend. Bye, everybody.